So today we're going to cover section 3. Most of the things that we're going to read about today are going to be converses of the theorems that we learned in lesson 7.2. So remember, a converse is where you switch the if and the then. So here is our first converse, and this one is the parallelogram opposite sides converse. Again, remember, you don't memorize the number. You're going to either memorize the name here, or you're going to memorize what it states. So this is the first way that we can prove that a quadrilateral is a parallelogram. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So notice in my figure, they have a congruency mark here on AB, which is congruent to CD, as well as BC being congruent to AD. If they want us to write this based off of our picture, what we could state is that if AB is congruent to CD, and if BC is congruent to DA, then ABCD is a parallelogram. And I'm just going to draw a picture of one instead of writing out the word parallelogram. So this is the first way to prove that a given quadrilateral is in fact a parallelogram. And this is the converse of what we saw in 7.2, where they told us that if it's a parallelogram, then opposite sides are congruent. The if and the then is switched. Anybody still need it? Okay, let's try the next one. Again, do not memorize the number. You can either memorize the name or what it states. And this one states, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So again, based off the picture, you could say if angle A is congruent to angle C and angle B congruent to angle D, then ABCD is a parallelogram. Notice that B and D have the same markings, so they're congruent, as well as A to C. This is our second way of proving that a quadrilateral is a parallelogram. If you know these very well, writing the proofs for this chapter are going to be easy. Anybody still need it?
Yeah, I'm still ready.
Okay. The next one is called the opposite sides parallel and congruent theorem. Now this one isn't a converse, this is something new. So what this one states that if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. It has to be the same pair. So notice in my picture, side BC and AD have both the congruent and the parallel marking. Those markings have to be on the same side, and I'm going to show you a scenario where it wouldn't work. But let me go ahead and base my statement off of this picture. So we could state that if BC is parallel to AD and BC is congruent to AD, then ABCD is a parallelogram. So again, the markings have to be on the same side. Let me show you a scenario where it wouldn't work. Let's say we had this picture of our parallelogram. Let's do the same order of the letters. A, B, C, D. Let's say the parallel mark was here, but the congruency mark was here. This would not be enough information. So you would not have enough information to show that this is a parallelogram. The parallel and the congruency marks have to be together on the same side. So this would be a fail. You would not be able to prove or use these kind of markings to use this theorem. Again, don't memorize the number. The name of it is the parallelogram diagonals converse. And this one states that if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So what we could state is if BD and AC bisect each other, then ABCD is a parallelogram. Based off the pictures, you could state that BE is congruent to ED and that AE is congruent to EC. If that happens, if you have that kind of markings, then you know that ABCD is a parallelogram. This is our fourth way of proving that a quadrilateral is a parallelogram. And then the other way is by the definition. That if you have two pairs of parallel sides, then you know it's a parallelogram. The next two slides are going to sum everything up. So it's just going to condense them all into one slide. And I'll show you that momentarily. Let's move on. So again, this slide summarizes what we just saw. The only thing that we did not talk about today was the first one, and this one is the definition of a parallelogram. The other ones are the converse and that one theorem where both sides are parallel and congruent. Everything else is just the converse. So these are the four properties and then the one definition. These are all ways to prove that a quadrilateral is a parallelogram. The next slide says the exact same thing, but it's got a picture next to it. Again, if I ever ask you a question, I shouldn't see you answer and tell me the number. You would need to restate the theorem or tell me the name of it. But I just wrote these on here just for a quick reference if you need to go back to see where it was listed in your notes. So it's the same as the previous slide, just a nice little summary here, but now it includes pictures. Everybody good? All right, let's go on. Let's start doing some examples. Now this next one's got a little bit of time, but again, it's just, again, reinforcing what we just covered. So in questions 1 through 5, it wants us to state, is it the definition that they're talking about? Is it a theorem or is it the converse? What are they using? So here, it's number 1 says that BE, and I'm going to make this congruent. It's kind of hard to do in PowerPoint. BE is congruent to ED, and CE is congruent to EA. Let's go ahead and add these to our picture to see where they're located. So BE is here, ED is here, CE here, congruent to EA. So we can see that they're talking about the diagonals here. So this tells me that this is going to be the parallelogram. I'm going to give you the name first. The parallelogram diagonals converse. That's the name of this one. But if you forget the name, tell me what this theorem states. And what this theorem states, and again, I'm just going to write it just so it makes maybe the memory a little bit more permanent. It says, if diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. That's what the diagonals converse says. The next one, I'm going to label my picture. So here it's telling me that angle BAD, which is here, is congruent to angle DCB, which is here, as well as angle ADC is congruent to CBA. Notice these are the opposite angles. So this should be a clue that the name of this one is the parallelogram opposite angles converse. And I'm going to go down to the bottom. So this was number 2. And I'm going to restate what that theorem or that converse states. So number 2, that theorem, the parallelogram opposite angles converse, states that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. That's what that states. Number 3, let me go ahead and add in the markings. So this one is stating that BC is parallel to AD and AB is parallel to DC. This is the definition of a parallelogram. So if both pairs of opposite sides are parallel, you have a parallelogram. Okay, let's try the next one. This time they're telling me that BC is congruent to AD and AB is congruent to DC. And actually, I've already used these markings. Let me make this 3, 1, 2, 3, and then 4, 1, 2, 3, 4. So this one, the name for this one is the opposite sides converse. So let me just write everything down here. Number 4 is going to be the parallelogram opposite sides converse. And what this one states is that if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. And the last one, and notice the markings are already here. So in my figure here, BC parallel to AD and BC congruent, this should be a congruent to AD. They've already been marked. So this one is that theorem that we learned that was new today. So this one is the opposite sides, parallel, and congruent theorem. And what this one states is that if one pair of opposite sides of a quadrilateral are both congruent and parallel, then the quadrilateral is a parallelogram. So again, a nice little summary of the 5 ways to prove that something is a parallelogram. Now we're going to try another application. Yes?
Remember 3, it was just the definition of a parallelogram.
Correct. And the definition states that if both pairs of opposite sides are parallel, then the quadrilateral, then it's a parallelogram. So here it's asking me for what values of x and y is quadrilateral PQRS a parallelogram. So for here, what I'm going to be using, if it asks you to explain what you were doing, you're going to use the parallelogram, opposite sides converse. This is what I'm using. So what I'm going to do, and again, yes, yes. What this states is if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So to find x, I am going to be setting PQ equal to SR. PQ is equal to x plus 9 and SR equals 2x minus 1. I need to get my variables together and my constants together. So I can minus x, 9 equals x minus 1, add 1, and I get x equals 10. And that's all it asked for. However, let's say the question didn't say just find x. Let's say it said find the length of PQ. So here's where you would take PQ, which is x plus 9, plug in 10, and you would find out that PQ equals 19. Same thing if it asks for SR. SR is 2x minus 1. 2 times 10 minus 1, 20 minus 1, and SR is 19. Remember that these opposite sides are congruent. If these two answers weren't the same, then you did something wrong. Okay? So when you're taking the quiz or the test on this, be careful and read what it's asking for. Now we're going to do something similar for y. We're going to set the opposite sides equal to each other. So now to find y, I am going to set PS equal to QR. PS is y and QR is x plus 7. Now you might look at this and you're like, oh my goodness, there's 2 variables. What do I do? Well, what we're going to do is we're going to take the value of x that we just found, which was 10, and we're going to put a 10 in here. So y is equal to 10 plus 7. Y equals 17. Now again, if it asks you to find PS, well, PS is y, and we just found that out, and it was 17. Or if they ask you to find QR, QR is x plus 17, 10 plus 17, or 7, and you get QR equals 17. Again, these two numbers should be the same. But final answer here, remember they were only asking for X and for Y, so you would just pick an answer that looked like this, or that's all you would put in as your answer. But again, I just wanted to show you that you could take it a step further to actually find the side lengths. Yes?
How did you know? Wait, why did you use opposite sides conjugate?
Because I needed to, it said for what values are X and Y, that quadrilateral or parallelogram. So in order to prove that it's a parallelogram, I would have had to shown that the sides were congruent. Because I didn't have anything about angles, all I had were the side lengths.
On the quiz, they were gonna have to say that.
We haven't finalized the quiz yet, so if it does ask you to explain, that's what you would put. Pretty good? Now we're going to do the same thing, but now we're going to deal with angles. Let's look at example 3. Is telling us that we need to find again what values for X and Y is this quadrilateral a parallelogram. So again, if it were to ask you to explain what you're using, we're going to be using the parallelogram opposite angles converse. So if the opposite angles are congruent, then our quadrilateral is a parallelogram. So what we would do is first to find X, I am going to set angle A equal to angle C, because these are opposite angles. So I'm going to set 3X minus 32 equal to 2X. I'm going to group my variables together. Negative 32 equals negative 1X. Divide by negative 1. And X equals positive 32. Same thing as before. This is the answer they wanted, but let's take it a step further. If they ask for angle A, we would be doing 3X minus 32. Replace X with 32. And then now solve the problem. 3 times 32 is 96. 96 minus 32 is 64 degrees. If I wanted to find angle C, 2 times X, 2 times 32 is 64. Again, remember these were congruent angles, so I should be getting the same answer. Now let's find Y. So again, we know opposite angles are congruent. So I'm going to set for Y equal to Y plus 87. Going to move my Y over. 3Y equals 87. Divide by 3, and Y equals 29. Again, let's say they want us to find the measure of angle B. B is equal to 4Y, 4 times 29, and I get 116. If they ask for angle D, it's Y plus 87. 29 plus 87 also gives me 116. But again, final answers here are X equals 32 and Y equals 29. Let's look at the last one. It's asking us to write a 2-column proof. Now, honestly, the proofs in this lesson are going to be pretty easy if you know your properties. A lot of them, you're just going to maybe look for a missing piece. Some of them might be a little bit more complicated where we may have to show that we have congruent triangles, and then from there we can show some more congruent pieces. But let's go ahead and see what we got here. So our picture's already labeled for us. It was given that ADB and CBD are congruent angles, and ABD and CDB are also congruent. So let me go ahead and set up my proof, my statement column, and my reason column. Let me go ahead and restate the given. So whenever you're tested on a proof, never leave that given off. So we're going to state that angle ADB is congruent to angle CBD, and ABD is congruent to CDB, and that's given. Now remember my 5 ways. I can either show that opposite angles are congruent, or opposite sides are congruent, or opposite sides are parallel, or one pair is both parallel and congruent. I can show that my diagonals bisect each other. These are all different things I can do. But what I'm going to do here is, because I have, if you remember, way back from before Christmas, these angle pairs are actually alternate interior angles. So watch what I can do. So if I have the diagonal here is my transversal, I could state that AD is parallel to BC because this angle is congruent to this. These are alternate interior angles, and I'm using the alternate interior angles converse. And then I could also say that AB is parallel to DC because of these alternate interior angles. So my next statement is going to be that AB is parallel to CD and that AD is parallel to CB, and that reason is the alternate interior angles converse. And we learned this before Christmas break. So this will be coming back to us, as well as the consecutive interior. Now that I've shown that I have both sides are parallel, by definition, this is a parallelogram. So my next statement, ABCD, is a parallelogram, and my reason is the definition of parallelogram. If both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. So that's all you have to do is put definition of parallelogram. So again, if you know your properties, if you remember your alternate interior, your consecutive interior converses, it helps, as well as showing that 2 triangles are congruent. You may have to use some of those shortcuts, like you did in that practice A. Let me show you just one additional proof, just to, reinforce that these are pretty easy proofs. So let's say we have quadrilateral, and it's got a congruent mark and a parallel, congruent, a parallel. It says, given that AB is parallel to DC and that AB is congruent to DC, it wants me to prove that AD is congruent to BC. So number 1, statement, reason. I'm going to restate the given, AB parallel to DC and AB congruent to DC. And that was given. Remember, this is one way to prove that something's a parallelogram, and that's what I'm going to state next. ABCD is a parallelogram. And that reason is the opposite sides parallel and congruent theorem. And that states if one pair of opposite sides of a quadrilateral are both parallel and congruent, then the quadrilateral is a parallelogram. Now, we weren't trying to prove that it was a parallelogram. We were trying to show that AB is congruent to DC. So I can go, and that's what I'm trying to prove. And my reason is the opposite sides theorem. So the parallelogram opposite sides theorem, or converse, sorry. Actually, theorem. This is the theorem, not the converse. And this one states, if you forgot, from 7-2, if a quadrilateral is a parallelogram, then opposite sides are congruent. And again, you don't need to state both. You could either just state the name, or if you forget the name, restate the proof, or the theorem, sorry. And that's how short and sweet these proofs are. If you know your properties and you can work with them, make sure it flows, the proofs aren't bad at all. Now, someone asked me in the chat, are there going to be any proofs on the quiz? I don't know yet. The quiz has not been finalized yet. But again, anything's possible if we've covered it in the notes or the homework. So yes, it could be possible. Again, we're still working on finalizing that quiz. So that is it for the notes on 7-3. You do have a homework assignment that's due tomorrow.